This is Layla Malgosa doing Mission Report 3, and I chose the size and age of the universe, and the background is the Milky Way in the universe today. So one of the ways astronomers estimate the age of the universe is by looking for the oldest stars. In order to find these older stars in the universe, they must study the globular clusters, which is a dense collection to close to 1 million stars, all of which formed at roughly the same time. So here's images of the globular clusters, and this is a closer version of it. Alright, so here's an image of how hydrogen is burning in the star. The middle is where all the energy source is. So if a globular cluster is more than 10 million years old, then all of its hydrogen-burning stars will be less massive than 10 solar masses. The oldest globular clusters are between 11 and 18 billion years. The life cycle of a star depends upon its mass. The higher the mass, the more rapidly the star burns through their supply of hydrogen. A star like the Sun has enough fuel in its core to burn at its brightest for approximately 9 billion years. So as you can see, this is how the Sun looked like in 1996 compared to 2000, and you can tell it drastically changed. So measuring the Hubble constant is another way to estimate the age of the universe. The measurement extrapolate back to the Big Bang was used by a cosmologist. The Big Bang occurred between 12 and 14 billion years ago. Here's an image of the Hubble view of a cosmological measuring tape. So if an astronomer estimates that 1/HO is as small as 10 billion years is correct, then the age of the universe would be shorter than the age of its oldest stars. This contradiction implies that either the Big Bang theory is incorrect, or that we need to modify general relativity by adding a cosmological constant. Here is a clip of the Big Bang. Alright, and here's my reference.